Hi, this is Al, your probability and statistics instructor. I hope you're doing well. Okay, time to start talking about probability theory. So, first, let me remind you that previously in another video we talked about basic set operations, right? Remember? We talked about their definitions and notation, right? Another thing that we did in that video was introducing two special and important sets, the empty set and the complement. And the basic operations that we talked about were union and intersection. Remember? Okay. What we're going to be doing next is doing something like that. We're going to be actually discussing the same example, but we are going to be using R to obtain the events that are the result of applying these operations on those events that we defined for that particular example. Well, let me remind you what was the example that we talked about in that video, where we provided the definitions for union and intersection. The example was this. We said that we were going to consider a simple random experiment, tossing a coin twice in succession. Suppose that you toss a coin twice in succession. That's a random experiment. So, just like before, let's obtain the sample space. Sample space, in this case, we're talking about the regular coin, HH, HT, TH, and TT. That's our sample space. Well, in order to talk about unions and intersections, let's define a couple of events. Okay, the first event would be A. The first toss results in heads. Okay, A. The first toss results in heads. Let's define another event, the event B. The event B that we defined back then was the second toss results in tails. B. The second toss results in heads. Well, and the first operation that we considered back then was the union of events. So, union of events. We know that we could use notation to refer to the union of these two events, A or B, right? That's the union. So A, and then notation union B, right? That's the union. Okay. And clearly, right, from what we did before, and from the definition of union, the union will be given by these three sequences. Okay, but we said we wanted to do this using R now, instead of doing it just by hand. Okay, so let's use R to do that. Let me make sure that you can see this. Let me increase the font size. Okay. So the experiment that we're interested in is just tossing a coin twice. Remember that I already asked you to download R, right? And I already asked you and showed you how you could install a library, a package that we're going to need to do these sort of operations, right? The name of the package, the name of the library that we're going to be using is prop. So I am assuming that you have already installed that library prop, and I'm going to call it so we can use it. Okay, so we said our random experiment of interest is tossing a coin twice. There's a function in that package, in that library, called toss, and then toss, and then brackets 2 will give us what we want. Oh, sorry. The right command is toss coin. We're tossing a coin twice, right? Okay, there we are. So that's the list of all possible outcomes for that simple random experiment. That's our sample space. We already know that. Okay, but we said we would like to be able to obtain the union of A and B using R. How do we do this? Okay, so first let me assign this object to an object called S. Okay, so we could use the equals sign and then toss coin, sorry. So once you do that, you make an assignment. If you want to see what is contained in that object you just created and that you called S, uppercase S, we have this, right? What we wanted. Okay, so now we are interested in defining two events, A and B, and the event A would be the first toss results in heads. So that would be the first element of S and the third element of S. How do we isolate those guys? Here goes. Uppercase S, then square brackets. If you do this, 1, comma, and then blank, let's see what happens. Oh, guess what? That is the first element of S. And we said that we are also interested in the third element of S. Those two elements together form the event that we defined as A. So how do we paste them? One way of doing this would be this. S square brackets C. C is a special function in R. It stands for concatenate, combine. So what we want to do here is combine 1 and 3. The first element, the first row of that matrix S that we have there, because it's basically a matrix, right? So we want the first and the third row of that matrix, and we want all the columns. That's why we have that blank space on the second position, because we are thinking about this array like a matrix. See, that guy is exactly what we need. That's exactly what we want for A. So once we have it, just let's assign those two elements to A, just to make sure that we have what we actually want. Retype the name of the object you created, A, the event that you defined, and that's the one that you want. Now we are going to be defining B similarly, but now instead of having the first row, what we want is the second row and fourth. I'm sorry, what we want is, the third and fourth rows, because remember that we defined B as the second toss results in heads. Okay, so it would be the third and fourth. Okay, and that is going to be B. Let's retype the name of the object we just created, B. Second toss results in tails. Makes sense. Okay, so now we know how we can define the sample space for this particular simple random experiment, how we can define subsets of the sample space, events that is, and now let's find out how we can do operations. The first one that we're interested in is union. So this library, this package that we're using, prob, has a special function, union, that is going to help us find the union of sets. Okay, union of sets A, the union of sets A and B, meaning A or B, right, is this. And that's what we found before by hand, and it makes sense. Are the elements that are in A or in B. Okay, so next up, the next operation that we are interested in is intersection. So how do we do that using R? We already have defined events A and B, so it turns out that if we want the intersection between A and B, if we want the event A and B, you need to use that special command, intersect. Just press enter, and that's it. Makes sense, right? That is the intersection between A and B, right? It would be the elements in the sample space that satisfy both conditions. So the first one, the first toss results in heads, the second toss results in tails. Great. The empty set. What we saw before is that the empty set could be the result of finding or being interested in a particular combination of events. So if we defined the following event, C is the first toss results in heads and the first toss results in tails, I'm sorry, that the first toss results in tails, just the first one. Okay, so if we defined C like that, the event the first toss results in tails, right, it is clear that A and C is the event the first toss results in heads, and the first toss results in heads, in tails. We know that the result will be the empty set. But how do we do that? Okay, how do we do that in R? So first, to be able to do this in R, we have to define our event C. So C is the first toss results in tails, right? So let's see, that's a sample space, so C would be defined by the second and fourth elements of the sample space. So let's do the same thing that we did before to isolate those elements from the sample space. Let's use the C function, the concatenate function. We want the second row, the fourth row of that array that represents the sample space, meaning the first toss results in tails. Okay, let's retype the name of that event we just defined, and it is what we want it to be. Now, to obtain the intersection, just use this this special command, intersect AC. And what you get is kind of a cryptic message at first, but now that you see it, oh, it makes sense. 0 rows satisfy that condition, meaning, oh, no elements satisfy that condition, and we know that the empty set is a set without any sample points, with no elements. Okay? Okay, so how about the complement? Can we get complements of sets using R? It turns out that we can. So, for instance, say that we were interested in a complement. Okay? The complement of the event A, and we know that the complement means that the event A does not occur. Okay, so we already have S, we already have the event A of interest, and since we want basically the difference between S and A, guess what? There's a function called setDiff and it gives you what we want, the complement. In this case, we know that the complement is given by all the elements in the sample space, right, where A does not occur. And since A is the first and third rows of this array, it makes sense that the complement will be the second and fourth rows of that array, TH and TT. Okay? So, homework problem, something that I would like you to think about. Could you express the complement as well in terms of unions and or intersections? Think about it. Okay? Well, summary of what we did today. Summary. We learned to use R to carry out operations using sets. The important functions in R. So if we want to find a union, this is what you want. Union is the special command that will do what you want. For intersection, there's a special command as well, intersect. And if you want to find the complement of an event A, this is what you have to do. Use the function set diff, okay, and find basically the difference between your sample space and the event A of interest. Finally, we said homework. Express a complement using basic operations, meaning union, intersection. Okay? Well, that's it for now. See you next time. Take care and keep working hard. Bye.